as I said, this is part of our tapas activities, and so we're very pleased to have what is our final speaker for this this year, before we take our summer break, is Claire Dassonville from France. Claire has been working for over 10 years as a research and expertise engineer in health and comfort department at the Scientific and Technical Center for Buildings in France. And they've been carrying out measurements and observations of indoor air quality and in schools for over a long time. And she's going to talk about the results from their nationwide study, which took place from 2013 to 2017. So we're very pleased to have you, Claire. And just to say that please put your questions in the chat, and I will moderate them at the end of Claire's presentation. Please stay, mute yourselves while Claire is talking, and we'll get to the discussion at the end. So over to you, Claire. Thank you very much. Now, I can't hear you, Claire. You're muted. Yeah, you're still muted. Okay, good.
Do you hear me?
I hear you now, yes. And you just need your slide back up again.
Yeah.
Okay.
Okay.
Good to go.
So thank you, Paul. Good afternoon, everyone. I'm pleased to be with you today. Thank you to the TAPAS networks for giving me the opportunity to present the results of the indoor air quality nationwide survey in French schools. This survey was carried out by the Indoor Air Quality French Indoor Air Quality Observatory. So last year, Corinne Mandin, who is my chief, presented on the French Indoor Air Quality Observatory and also the main results of the nationwide survey in schools. So today, my talk will focus on a study we carried about with the data from the nationwide study. It aims at studying multi-pollutions and associated building characteristics. There is a need to describe chemical mixture to which children are exposed to better assess associated health effects. But first, I will start with a short presentation of the French Indoor Air Quality Observatory, and I also will present you the nationwide survey in school through objective methods and the main results. So the French Indoor Air Quality Observatory was a research program created in 2001, granted by ministries in charge of housing, health and environment, and also public health agencies like ADEME and ANSES in France. It aims at improving knowledge on indoor air quality in buildings in order to provide support for public policies, but also it aims at publishing recommendations for professionals and general publics. In the frame of this research program, we carried out campaign at the national scales, and particularly a survey in school. So the objectives of the survey in French schools was to measure air and dust pollutants and comfort parameters in nursery and elementary schools in mainland France. children who attend nursery school in France are from 2-year-old to 6-year-old, and children who attend elementary schools are 6-year-old to 12-year-old. So every nursery and elementary school in France was infeasible. So selections of some of school was performed from a database of schools of French Ministry of National Education in 2009. The schools were randomly selected, and the sample was stratified on 3 parameters, which can have an impact on indoor air quality. The level of school, nursery or primary, the type of environment, urban or rural, and also the climatic zone defined by the 2005 French thermal regulations. And you can see here these climatic zones on the chart here. So in each strata, school shares similar characteristics. So 301 schools were selected, and in each schools, 2 classrooms were also randomly selected. A post-survey adjustment was implemented, so the sample of schools gets more similar to the stock of the French school. So the initial sampling weights were replaced by final calibrated weights, and the sum of the final calibrated weights was equal to the size of the French stock of schools here. The sampling unit was school, so all the results were expressed at the school unit, at the school scale. So field measurements were performed from 2013 to 2017 over a school week, from Monday morning to Friday afternoon. All the devices, our devices, were placed in a carrier. You can see here on the picture, and the carrier was plugged in the classroom. So online measurements were done over the week for carbon dioxide, temperature, relative humidity. Particle counting were also monitored with an optical counter over the week. And noise levels were monitored over 7 days. The measurement started the Friday before the monitoring week, in order to have the background level, the sound level in the weekend. Air samples were also done. Active samples with pump for fine particulate matter, PM 2.5, and also semi-volatile compounds, SVOC. And VOC, aldehydes, and nitrogen dioxide were monitored with passive sampler over the week. The sampling were performed for wipe for the lead, and also with a modified vacuum cleaner for lead and other metals, and also SVOC in dust. Spot measurements were done. High luminance on tables and boards was measured due to artificial light in the classroom with an illuminance meter. We use a illuminance meter. Lead in paints was measured by X-ray fluorescence, and these measurements were done by technicians. We were authorized to carry radioactive sources. Radio frequency, electromagnetic field were also measured by the French frequency agency according a specific protocol. In parallel, we collected information about classrooms and building characteristics by questionnaires. And this questionnaire were fulfilled by field technicians. Children's and teacher attendance over the week was noted by a teacher over the week every 13 minutes. And at last, teacher and children perceptions of noise, lighting, noise lighting, and was collected by a self-administered questionnaire. So what are the results? Here are the main results. If you want more information, please let's see current slides. We observe positive aspect with low NO2 concentrations in French schools. And also indoor VOC concentrations were lower in schools than in dwellings. But we identify 4 critical issues. The first one is fine particulate matter, PM2.5. Yes. PM2.5 were ubiquitous in French classrooms. They were detected in at least 1 classrooms of quite all schools, and concentrations exceeded the WHO threshold of 5 micrograms per cubic meter in at least 1 classroom of quite all schools. So it is of concern. The second point is semi-volatile organic compounds. Some of these SVOC were also detected in at least 1 classroom of quite all schools. And it is of concern because some of these VOC are suspected or recognized to be endocrine disruptor. We also observed a lack of ventilations and high air stuffiness, but it's common in school and it is known in schools. And the last point is lead. Indeed, 15% of schools had at last 1 classroom in which there were deteriorated paint containing lead. So now let's move to the study about multi-pollutions and building characteristics. This study was published in the Energy and Building Review in 2021. The objective of the study was first to identify a cluster of classrooms that shared the same profiles in terms of indoor pollutions, in dust and air. And then to study the building characteristics associated with these profiles. So we carried out a statistical analysis on estimations on the sample of classroom. We didn't use estimation extrapolated to the French zones of school building. It was too complicated. 78 pollutants in air and settled dust and also climate parameters were included in these analysis. And 54 parameters collected by questionnaire describing school buildings and classroom were also included. So first, there was a large number of pollutants. So in order to reduce the correlation between pollutants and to have a sparse model, a clustering approach was applied to this pollutant, and it led to have 36 clusters, 36 groups of pollutants. You can see here. These clusters are the finest and the best grouping according the correlation between the pollutant. So here there are some clusters among the 36 clusters, and this cluster differentiate chemical families and also sample median. Here in the cluster 1, you have PCB only in dust. Here we have polycyclic aromatic hydrocarbons only also in dust. Here VOC in air. Here PAH in air also. In cluster 11, we have pollutant which originate for different chemical family. We are here benzoapyrene, which is a PAH, and benzene, and NO2 and PN2.5. But all these pollutants come from road traffic. So one pollutant was selected from each cluster, and these pollutants were included in a classroom clustering. Clustering approach is useful to analyze a large set of multidimensional data. It allows organizing and summarizing the data in clusters that share the same similarities, and it allows highlighting the main features. Clustering approach has been widely used to study outdoor air pollution, to study spatial, temporal variability, but also pollutant behavior, relation with meteorological conditions. But this approach was less used for indoor environment. Very few studies used this clustering approach to study multi-pollution in indoor environment. And the studies have been dealt with mainly with dwellings, but less with school. So this classroom clustering help us to identify 5 clusters of classroom. You can see the cluster on the chart here. The characteristic variables of this cluster were determined by studying a test value, and a test value assessed the difference for the variables between the cluster and the entire samples. So the first cluster, here in red, included classroom considered as multi-polluted in air and settled dust. It represents 21% of classroom. So in this cluster, concentrations of 28 compounds in air and 45 compounds in dust were higher in this cluster than in the entire sample. You can see here those compounds. So they are organochlorine pesticides and DDT, DDR, and here you have lindan and its isomer. Lindan is a widely used insecticide. It has been banned now in France for 20 years, more than 20 years. But this pollutant is very persistent in the environment, and it is always detected in indoor environment. And in French schools, it was detected in quite all the classrooms in air and dust. It is of concern because lindan is recognized, has been recognized to be endocrine disruptor. Another chemicals were PCB. PCB has been banned in France for a long time, 30 years, but they were always relieved by building materials produced before the ban. They used in numerous projects, electrical transformer, for example, but also in paint, adhesives, and also joints in, excuse me, but also sealant and caulking in buildings. There are also masks here. Masks synthetic musk are used as fragrance in numerous consumer products, such as cosmetics or cleaning products, but also phthalates, also widely used in numerous consumer products, particularly in plastic products and PVC. And we have also here PAH. Source of PAH is combustions, and due to lack of combustions in classroom, these pollutants come from the outdoor air. And we have also some metals in dust. In this cluster, VOC concentrations and NO2 concentrations were lower than in the classroom of the entire sample. So what are the characteristics of classroom? Those buildings are relatively old, mainly built, you see, between 1968 to 1981. And most of the building had undergone a retrofit over the last 10 years. Classrooms had more wooden floor and painting ceilings compared to ceiling tiles in more recent buildings. And most of the buildings have no ventilation system, and average air exchange rates was lower in this cluster than in the entire group. This building also exhibited more signs of dampness than in the classroom of the entire samples. The second cluster included classroom considered as multipolluted in air. It represents 19% of classroom. In this cluster, indirect concentration of 27 compounds were higher than in classroom of the entire samples. There are aldehydes, VOC here, but also phthalates, PAH, and lindan, but only in air. And quite all the pollutant concentrations in dust were lower than in the classroom of the entire sample. What are the classroom characteristics associated with this pollutant? They were building mainly in urban areas here with higher outdoor VOC concentrations. This could be linked to indoor VOC concentrations. There were mainly elementary schools. Classrooms have more wooden floor. And as for the previous cluster, most of buildings have no ventilation system. Air exchange rates were lower than in the classroom in the entire sample. And also, air stuffiness was higher in this classroom. Air stuffiness was assessed by the IEQ index built by CSTB. The third cluster included classroom multipolluted in settled dust. It represents 24% of classroom. And in this cluster, all indoor concentrations of the pollutants were lower than in the entire sample, except for some VOC. Here you see benzene, toluene, and benzoapyrene. And most of the pollutant concentrations in dust were higher than in the entire samples. So these buildings are mainly in urban area with higher outdoor VOC concentrations associated with the VOC and also the benzoapyrene here. It indicated probably the proximity of the building to road traffic. These buildings are mainly nursery schools in Mediterranean climate zone, and these buildings are less renovated. An interesting point, regular wet cleaning of the floors and also windows is more common in this cluster, and it could be linked probably to the higher concentration of musk and also phthalate in dust air. The fourth cluster include classroom considered as low polluted, except for two phthalates, DINP and DIPP. It represents 17% of classroom. In this cluster, all the pollutant concentration in indoor air and dust were lower than quite all, than in the entire samples, except two phthalates, DIBP and DINP in air and dust. And in this classroom has quite all the classroom, excuse me, had a plastic flooring here. So the plastic flooring is associated with probably with the presence of phthalates in air and dust. These buildings are relatively recent, mainly built after 1982, and most of the building has a mechanical ventilation system. The air stuffiness was relatively low. They exhibit lower sign of dampness, but higher indoor mean temperature in this classroom than in the entire sample. And the last cluster include classroom considered as low polluted in air and dust. It represents 19% of classroom. In this cluster, quite all the pollutant concentrations in air and dust are lower than in the entire sample, except for arsenic in dust. And these buildings are mainly in rural area, or arsenic occurs naturally in the earth's crust and in soil. So the concentrations of arsenic is probability associated with the concentrations of arsenic in the soils in the rural area. In this cluster, VOC, outdoor VOC concentrations were lower than in the other classrooms, and these buildings were relatively recent, built after 1982. And most of these buildings have mechanical ventilation system, and average air exchange rates were higher in this classroom than in the entire system. So if we look at the main results, our study highlights 5 profiles of indoor air pollutions in air and dust. And we also see that a large majority of classrooms are multi-polluted. And the factors that affect indoor air pollution are first the age of buildings. Yes. Multi-polluted classrooms were found in all buildings. Also, the type of outdoor environment, urban, is associated with VOC, higher VOC concentrations, but also rural area was probably associated with metal arsenic in dust. The type of flooring, and particularly plastic flooring in classroom with phthalate concentrations. Also, the sign of dampness. Dampness in building materials increase the emissions from these materials. And the last one, the presence of a system of ventilation in classroom, and also the air exchange rate have a great influence on multi-pollutions in classrooms. So to conclude my presentations, what are the next steps? Currently, the regulatory formaldehyde guideline value, and also the indoor air quality monitoring of schools, building and daycare center has been revised. So the ministry in charge of environment had questions about the relative contribution of building characteristics and other parameters on indoor formaldehyde concentrations. We carried out a statistical analysis to identify formaldehyde determinants from the nationwide survey data. In parallel, we work on a project with the city of Lyon. We analyzed formaldehyde and benzene concentrations from the indoor air quality, from the regulatory indoor air quality monitoring. And we analyzed this concentration to identify formaldehyde and benzene determinants in these schools. This is a large data set with more than 1,000 measurements of formaldehyde and benzene. The results and the reports of these two projects are not still available, but I can just say that results are similar in the two projects, and the results highlight the great impact of air renewal on formaldehyde concentrations. And another project is ongoing. This project will allow us analyzing high luminance data and also noise level. It aims at adapting the tail index to school. It is a PhD thesis of Mintien Tran. The tail index was developed to assess the indoor environment quality of offices and hotels undergoing deep renovations. It was developed by CSTB and also the University DTU of Denmark in the frame of European Aldrin project. And this index allows rating the overall quality of indoor environment through the four components: air, thermal, acoustic, indoor air quality, and lighting. So the tail index will be developed for school, and then the efficacy of this index will be examined on the dataset of the nationwide survey. So I am finished. Thank you very much for your attention.
Yeah, thank you very much, Claire. I'm sorry, I was trying to press my unmute button. That's a very interesting presentation. And I'm going to look in the chat. I'm not sure there are any questions in the chat at the moment. I don't see any. So if anyone would like to ask a question, please unmute yourself and ask Claire directly. And while you're doing that, I'll start off with a question. This survey you did of all of these schools, were the weeks throughout the whole of the year? So there were weeks in the winter and weeks in the summer, for example?
The field management were also performed during the scholar period from September to June.
Right.
So we have more measurement in heating season than in hot season.
Right. And did you see any major differences between measurements taken in the heating season and in the hot season? And did you try and make any distinction between them?
We take into account in the multi-pollution study, we take into account of the season of the field measurement, but we don't really directly analyze the influence of the season of indoor pollutant and or dust pollutant, indoor air pollutant and dust pollutant. No. We just take into account of the season in our statistical analysis, but not directly the influence of the season. We have not this result.
Right. Okay. Anyone else like to ask a question? If not, can I ask a second?
I have one question.
Yeah, please go ahead, Akim. How are you?
Claire, thank you very much. A very fascinating presentation. I noticed that it seems the air quality was a lot better on mechanical ventilated rooms compared to, not having any ventilation. Was there any like follow-up after the study to like retrofit schools or classrooms and, put ventilation systems into place? Or is that also something that is considered now to be done more? Would be great to hear a little bit about that.
I'm sorry, I don't catch your questions. Do you mean indoor quality was better with in classroom with mechanical ventilation system? Yes, that's it. And what is your question?
That's how I understood the result, that the classrooms that had the mechanical ventilation had less pollutants inside that you could measure. So my question was like, to what extent is that considered a kind of best practice now to put into classrooms? Or was there any kind of result based on that? Like, what should be an ideal classroom? Should it have mechanical ventilation or not, for example?
Yes, I understand. It's a great question. I think it's, but it is very complex. I'm not sure I have the answer to these questions, but I think it is case by case. And indoor quality have to be included in the retrofit. I've been included. I'm sorry. I've been included in the retrofit. But not at the end of the retrofit, at the start of the retrofit. So you have to think about indoor quality and look at all the building characteristics, especially outdoor environment and also indoor sources. And it's case by case. Ventilation system must be put in the building, for example, if it's necessary, but ventilation by windows opening could also be convenient if outdoor pollution is low, for example, and teacher opens the windows regularly during the day, during the school day. I'm not sure I have answered to your questions. It's difficult for me to explain in English. But,
okay, thank you, Claire. I think
I'm sorry.
Yeah.
I think that was clear. Thank you. Does anybody else have a question for Claire? Can I just ask Claire, are all these data, are they published somewhere?
Data about multi-pollutions, yes, were published, but not the data, the main results of the survey. It is a report in French, and the report is still not available on our website, but it will be available shortly now.
Okay, oh good, thank you. Okay, well I
think
it
is in French.
I'm sure we can manage. At least the graphs are understandable to most of us. So if anybody else have a final question? If not, I'll just like to close this and thank Claire again for a very interesting presentation. I think it's an amazing study that you carried out over this period, and a great data set, and I'm sure lots of lessons can be learned from it over time. And I hope we'll be able to compare with some of our measurements in the years to come. So thank you very much, everyone. As I said, this is the last in the series, our Thursday lunchtime seminars. And we'll take a break now until we reconvene in October after the summer break. But keep your eyes open for emails. And as usual, all Claire's talk, along with all the previous seminars, are on our website. So if you would like to catch up on this, please do that. And we'd always like to hear from you. We're an open network, and we're open to comments and thoughts from anyone. So if you'd like to do that, please email Kat, and we'll respond to thoughts and activities. Okay, and so Kat's put the web address in the chat, and I think that just leaves me to say thank you again, Claire, and thanks everyone. And
thank you very much for inviting me.
We'll see you in October. Okay, bye-bye.
Bye-bye.
Bye-bye.